In 1980, Carl Sagan stood before television cameras and said something that would echo across decades. The cosmos is all that is, or ever was, or ever will be. He understood that our search for cosmic truth required both boundless curiosity and unwavering scientific rigor. Today, an object designated 3I Atlas races through our solar system at 61 kilometers per second, and it presents exactly the kind of opportunity Sagan spent his life preparing us for. Not an opportunity for wild speculation, but for careful scientific investigation. Not a chance to abandon reason, but to apply it more rigorously than ever. This is the third confirmed interstellar object to visit our solar system. The first two, Oumuamua and 2I Borisov, sparked intense scientific interest and, inevitably, speculation about their origins. Now 3I Atlas joins this exclusive catalogue. Some researchers, including Professor Avi Loeb of Harvard University through his Galileo project, have proposed that certain interstellar objects might warrant investigation for signs of extraterrestrial technology. This is precisely the kind of moment where Sagan's voice matters most. His philosophy, his method, his balanced approach to the extraordinary. Sagan taught us something crucial about this exact situation. He said, "It's really okay to reserve judgment until the evidence arrives." He dedicated his life to searching for extraterrestrial intelligence, leading SETI research, placing messages on the Pioneer and Voyager spacecraft that now drift in interstellar space. Yet when asked about alien life, his answer was always measured. "It would be astonishing to me if there weren't extraterrestrial intelligence, but of course there is still no convincing evidence." If you want to honor Sagan's legacy of cosmic exploration grounded in scientific thinking, join us in this journey. Subscribe to continue examining the universe through the lens of wonder and reason that Sagan championed. Share this perspective with others who seek truth over sensation. What would Carl Sagan have made of 3I Atlas? To answer that question, we need to understand both the object itself and the man who taught us how to think about such mysteries. 3I Atlas was discovered through systematic sky surveys, the kind of methodical observation Sagan championed. Its orbital characteristics immediately marked it as extraordinary. The eccentricity of 6(1)37 means its orbit is hyperbolic, not bound by our sun's gravity. This object came from somewhere else, traveled through the vast distances between stars, passed through our solar system, and will continue into the cosmic ocean beyond. Its velocity of 61 kilometers per second, relative to our sun, confirms this interstellar origin. Telescopes around the world turned their instruments toward 3I Atlas. The James Webb Space Telescope, launched decades after Sagan's death in 1996, but fulfilling his vision of ever more powerful eyes on the cosmos, captured detailed observations. Ground-based observatories contributed spectroscopic data. What emerged was a picture of a comet, showing the characteristic behavior of volatile materials sublimating as it approached the inner solar system. Sagan would have been fascinated by this process of discovery. In Cosmos, he wrote about the scientific method as humanity's most powerful tool for understanding reality. Here it was in action. Observation, measurement, analysis, hypothesis testing. No shortcuts, no assumptions, just careful accumulation of evidence. The composition data revealed elements and compounds consistent with natural cometary material. Water ice, carbon dioxide, simple organic compounds. These are the building blocks we find throughout space, the chemistry that emerges from stellar processes and interstellar clouds. Nothing in the spectroscopic signature suggested artificial materials or unusual isotopic ratios that might indicate technological origin. But let us apply what Sagan called the cosmic calendar to understand what 3I Atlas represents. If we compress the universe's 8 billion year history into a single year, stars like our sun form around September. The first interstellar objects begin wandering between star systems soon after. By the time Earth forms in early September, the galaxy is already filled with countless rocky and icy bodies ejected from young planetary systems. When the first humans appear at 11:59 p.m. on December 31st, these cosmic wanderers have been traversing galactic space for billions of years. 3I Atlas might have been traveling for millions of years before entering our solar system. It could have originated from a planetary system forming around a star we cannot even identify. Think about that journey. While human civilizations rose and fell on Earth, while species evolved and went extinct, this frozen remnant of another star's family sailed silently through the void between stars. Sagan taught us to use analogies to make the incomprehensible comprehensible. Imagine Earth as a grain of sand on a beach. Our solar system would span a few meters. The nearest star would be another beach kilometers away. 3I Atlas crossed that distance. It traversed emptiness so profound that light itself takes years to bridge the gap. The sheer physics of this journey reveal why interstellar travel is so challenging. No rocket, no engine, no propulsion system humans have yet conceived could efficiently cover such distances. The mathematics are unforgiving. To travel between stars in reasonable time frames requires velocities approaching a significant fraction of light speed. The energy requirements scale exponentially. This is why Sagan, despite his enthusiasm for searching for extraterrestrial intelligence, remained skeptical about interstellar visitation. He understood the numbers. He respected the physics. When we observe 3I Atlas moving at 61 kilometers per second, we are seeing an object moving at roughly 0.02% of light speed. This is consistent with natural ejection velocities from planetary systems, where gravitational interactions fling objects into interstellar space. If this were a technological probe, we might expect different characteristics. Course corrections, deceleration near the sun, organized signals. None of these have been observed. Sagan faced similar speculation throughout his career. When the first interstellar radio signals were detected, some assumed they must be alien transmissions. Sagan helped establish that they were pulsars, rapidly rotating neutron stars with natural electromagnetic emissions. When unusual radio bursts were recorded, he urged careful analysis before concluding they were messages. When spacecraft detected unexpected anomalies, he advocated for exhaustive conventional explanations before invoking the extraordinary. This brings us directly to Sagan's most famous methodological principle. He did not originate the phrase, but he popularized it and applied it rigorously. Extraordinary claims require extraordinary evidence. This is not closed-mindedness. This is not refusing to consider possibilities. This is recognizing that the more unusual a claim, the more certain we must be before accepting it. Professor Avi Loeb's Galileo project represents a legitimate scientific effort to investigate unusual astronomical phenomena, including interstellar objects. The project uses professional telescopes and instruments to gather data. This is how science should work. When Loeb suggests that Oumuamua's unusual acceleration might warrant investigation for artificial origins, he is proposing a hypothesis that can be tested through observation. Sagan would have supported such investigation while maintaining the high evidentiary bar. But Sagan would also have cautioned against premature conclusions. In his book The Demon-Haunted World, he outlined what he called the baloney detection kit, a set of tools for critical thinking. Apply those tools to 3I Atlas. What do we actually observe? A comet-like object with natural composition, following physics-consistent trajectory, showing expected sublimation behavior. What do we not observe? Signals, course changes, unusual materials, energy emissions inconsistent with natural processes. Sagan understood something profound about the human tendency toward pattern recognition. We evolved to detect agency, to see intention in phenomena. This kept our ancestors alive when rustling grass might mean a predator, but it also makes us prone to seeing purpose where none exists. He wrote, "We are pattern recognition machines, it's what we do, and we're so good at it that we sometimes find patterns that aren't there." The search for extraterrestrial intelligence, which Sagan pioneered, is based on a sound statistical argument. With hundreds of billions of stars in our galaxy alone, and hundreds of billions of galaxies in the observable universe, the probability that Earth is the only place where life and intelligence emerged seems vanishingly small. Sagan believed this. He devoted his career to it. But belief in the probable existence of extraterrestrial intelligence is very different from concluding that any given unexplained phenomenon must be extraterrestrial. This distinction is crucial. Sagan could simultaneously hold that intelligent life almost certainly exists elsewhere, while maintaining that we have no convincing evidence of contact or visitation. These positions are not contradictory. They reflect different evidentiary standards for statistical probability versus specific claims. Consider what Sagan said about the famous Drake equation, which estimates the number of communicative civilizations in the galaxy. He helped refine this equation, debated its parameters, used it in his teaching. But he always emphasized its uncertainty. We simply do not know values for most of the terms. How often does life emerge? How often does it develop intelligence? How long do technological civilizations persist? These are empirical questions without empirical answers yet. 3i Atlas provides one tiny data point in a cosmic calculation. It confirms that objects move between star systems. This we already knew from theory, but direct observation strengthens confidence. It demonstrates that interstellar space is not empty, but contains ejected material from planetary formation. It shows us that we can detect such objects with current technology, suggesting that a comprehensive catalogue might eventually be compiled. What would surprise Sagan about our current era? Perhaps the sheer number of exoplanets we have discovered. When Cosmos first aired in 1980, the existence of planets around other stars was theoretical. Today we have confirmed thousands. Sagan would have been thrilled by this vindication of his reasoning. If planets are common, then potentially habitable planets are likely numerous. The question becomes not whether such worlds exist, but whether we can detect signs of life on them. The James Webb Space Telescope, observing 3i Atlas and countless other objects, represents technology Sagan could only dream of. Infrared observations penetrating dust clouds, spectroscopy capable of analyzing atmospheric composition of distant worlds, imaging resolution revealing structures light years away. Each of these capabilities moves us closer to answering the questions Sagan posed. But advanced technology does not eliminate the need for critical thinking. In fact, it makes critical thinking more essential. More data means more potential for both discovery and error. Better instruments means we detect fainter signals, which requires better techniques for distinguishing genuine phenomena from noise. Sagan's skepticism was not about refusing to look. It was about looking carefully. When the Viking landers touched down on Mars in 1976, Sagan was involved in designing experiments to search for Martian life. The results were ambiguous. Some reactions suggested biological processes, others suggested chemistry. Sagan urged caution. He wanted more missions, better experiments, additional data. He died before Mars rovers confirmed that Mars once had liquid water, that it had conditions potentially suitable for life. He would have been fascinated by what we have learned, frustrated by what we still do not know, and insistent on continuing the search with rigor. The parallels to 3i Atlas are instructive. We have observations, we have data, we have theories that fit those observations. But observations can be refined, data can be extended, theories can be tested further. This is the ongoing process of science, not a final pronouncement. Sagan's vision extended beyond individual discoveries to humanity's long-term future. In Pale Blue Dot, he reflected on the famous photograph of Earth taken by Voyager 1 from the edge of the solar system. That tiny pixel of light, suspended in a sunbeam, contained everyone and everything humans had ever known. He wrote, "Look again at that dot. That's here. That's home. That's us. On it everyone you love, everyone you know, everyone you ever heard of, every human being who ever was, lived out their lives." From the perspective of 3i Atlas, passing through our solar system, Earth is even less significant. A pale blue dot orbiting an ordinary star, itself one of hundreds of billions in a galaxy that is one of hundreds of billions in the observable universe. This cosmic perspective was central to Sagan's philosophy, not to diminish human importance, but to contextualize it, to remind us that we are simultaneously insignificant on cosmic scales and precious as the only known bearers of consciousness. What does 3i Atlas's journey teach us about our own planet? Every world, every moon, every comet and asteroid formed from the same interstellar material. We are made of star stuff, as Sagan famously said. The atoms in our bodies were forged in the hearts of distant stars, scattered through space by supernova explosions, incorporated into nebular clouds that collapsed to form new stars and planets. The calcium in our bones, the iron in our blood, the oxygen we breathe, all originated in stellar furnaces. When 3I Atlas passes by, carrying ice and rock from another star system, it reminds us that planetary systems are not isolated. They exchange material. Over billions of years, rocks blasted from Earth by meteor impacts might reach other star systems. Conversely, material from other worlds has fallen on Earth. We are connected to the cosmos not just conceptually, but literally. This realization carries responsibility. Sagan was passionate about environmental protection, nuclear disarmament, and the long-term survival of human civilization. He saw these as cosmic imperatives, not just political issues. If consciousness is rare in the universe, and if Earth is the only place we know it exists, then preserving Earth's biosphere becomes a matter of cosmic importance. He testified before Congress about nuclear winter, the climatic catastrophe that would follow nuclear war. He spoke about climate change before it became widely recognized. He advocated for the colonization of space not as an escape from Earth's problems, but as a backup for life itself. All of this flowed from his cosmic perspective, his understanding of how fragile and precious the conditions for life are. Current research programs continue Sagan's work. SETI searches persist, using radio telescopes to scan the sky for artificial signals. New approaches look for optical flashes, laser communications, or even waste heat from advanced civilizations. The Breakthrough Listen project, funded privately, represents the most comprehensive SETI effort yet undertaken. Projects like the Galileo Initiative investigate anomalous observations with scientific methods. Where does 3I Atlas fit into this larger context? It joins a growing catalogue of interstellar objects. Oumuamua, discovered in 2017, was the first. Its elongated shape and slight acceleration sparked speculation. Detailed analysis suggested natural explanations, outgassing from sublimating ice providing the observed thrust. 2I Borisov, discovered in 2019, behaved more clearly like a typical comet. 3I Atlas continues the pattern, providing more data about how common such visitors are. Statistical calculations suggest that at any given moment, several interstellar objects are passing through the inner solar system. Most go undetected because they are small, dark, or positioned where our surveys do not look. As telescope networks improve and automated detection systems become more sophisticated, we will discover more of these cosmic wanderers. Each discovery teaches us something about the galaxy's dynamics. How efficiently do planetary systems eject material? What are typical compositions? How do objects change during millions of years of interstellar travel? Over time, patterns will emerge. We may identify objects clearly originating from specific types of star systems. We might detect families of objects sharing composition and trajectory, ejected together from the same catastrophic event. Sagan would have been excited by this growing dataset. Each new observation constrains theories about planetary formation, galactic evolution, and the prevalence of different materials in space. This is how science progresses. Not through single dramatic revelations, but through patient accumulation of evidence, gradual refinement of models, incremental approach toward truth. But he would also have warned against complacency. Science requires constant vigilance against bias, error, and wishful thinking. It requires institutions that support rigorous investigation even when results are mundane. It requires education that teaches people how to evaluate evidence. It requires a culture that values truth over comforting falsehoods. In the demon-haunted world, Sagan wrote about pseudoscience, conspiracy theories, and the importance of scientific literacy. He worried about a future where people lose the ability to distinguish between claims supported by evidence and claims based on belief or intuition. He saw this not just as an intellectual problem, but as a threat to democracy and civilization. We live in that future now. Claims about 3I Atlas circulate online, ranging from measured scientific analysis to wild speculation about alien spacecraft. The challenge for anyone seeking truth is distinguishing reliable sources from unreliable ones. Sagan's advice remains relevant. Look for peer-reviewed publications. Check whether claims are supported by multiple independent observations. Ask whether proposed explanations are consistent with known physics. Demand transparency about methods and data. The scientific consensus on 3I Atlas, based on current observations, is that it behaves consistently with a natural comet from another star system. This consensus can change if new evidence emerges. That is how science works. But the standard for overturning consensus must be high, proportional to the extraordinariness of the alternative claim. Sagan spent years combating sensationalism about UFOs, ancient astronauts, and paranormal phenomena. He did this not because he was closed-minded, but because he understood the importance of evidence. He investigated claims personally, analyzed purported photographs, interviewed witnesses. Almost always, conventional explanations proved sufficient. Misidentified aircraft, optical illusions, hoaxes, wishful interpretation of ambiguous data. Yet Sagan never claimed that extraterrestrial visitation was impossible. He acknowledged it as a possibility, while pointing out that possibility does not equal probability or proof. This nuanced position often frustrated people who wanted simple yes or no answers. But nuance is essential for honest engagement with reality. What are the implications of 3I Atlas for the search for extraterrestrial intelligence? Primarily, it confirms that objects do travel between stars, making interstellar panspermia theoretically possible. If life originated in one star system, could it spread to others via comets and asteroids? Microbes might survive the journey in frozen ice. Upon reaching a suitable planet, they could potentially seed it with life. Sagan and his colleague Edwin Salpeter explored this hypothesis. They calculated survival probabilities for microorganisms during interstellar transit. The numbers were not encouraging, but not impossible either. Radiation damage, cosmic ray exposure, extreme cold, and millions of years without metabolism pose severe challenges. But life has proven remarkably resilient on Earth, surviving in the most extreme environments. If panspermia occurs, it has profound implications for the prevalence of life in the galaxy. Instead of life needing to originate independently in each system, it could spread from common sources. This might mean life is either more common than we think, if initial genesis happened in many places, or more rare, if it originated only once or a few times and spread from there. But this remains speculation, admittedly fascinating but unsupported by direct evidence. We have not detected life beyond Earth. We have not proven that microbes can survive interstellar journeys. We have not shown that they could successfully colonize new worlds upon arrival. These are testable hypotheses awaiting data. 3I Atlas will not provide definitive answers, but it is part of the accumulating evidence about how the galaxy works. Each interstellar object detected tells us something about the population of such objects. Eventually, we may have enough data to estimate how many objects pass through each year, what typical compositions are, whether any show characteristics inconsistent with natural origins. This is patient science. Sagan excelled at communicating both the excitement of discovery and the patience required for it. He understood that most days in science are not filled with breakthrough revelations, but with careful measurement, analysis, and incremental progress. Yet he never lost his sense of wonder. Each new fact about the cosmos was to him a gift. He had a gift for conveying scale in ways that resonated emotionally. When describing the cosmic calendar, he made billions of years comprehensible. When discussing the pale blue dot, he made cosmic insignificance profound rather than depressing. When talking about star stuff, he connected us intimately to the universe. These techniques were not merely rhetorical flourishes. They were tools for changing perspective, for helping people see themselves and their world differently. Sagan believed that the cosmic perspective, properly understood, made people better, more humble yet more confident, more aware of fragility yet more determined to protect and preserve, more conscious of mortality yet more appreciative of the time we have. His legacy lives in every person who looks up at the night sky with informed wonder. It lives in the spacecraft, still operating decades after launch, carrying his messages to potential cosmic neighbors. It lives in the scientific programs, searching for extraterrestrial intelligence, the environmental movements protecting Earth, the educational initiatives teaching critical thinking. When Carl Sagan died in 1996, he left unfinished work. Questions he posed remain unanswered. Searches he initiated continue. Technologies he envisioned are only now being realized. But his method endures. His insistence on evidence, his celebration of wonder, his integration of cosmic perspective with human concern. 3i Atlas proves Sagan right not because it is an alien spacecraft, but precisely because it is not. It proves him right because it demonstrates that the universe is filled with natural wonders requiring no supernatural or technological explanation. It proves him right because it shows that patient observation and careful analysis reveal truth more effectively than speculation. It proves him right because it reminds us that we are part of a vast, ancient cosmos filled with processes and objects that dwarf human concerns, yet connect to our deepest questions about existence. We continue his mission by looking up, by questioning, by demanding evidence, by celebrating discovery. Every time we choose reason over superstition, evidence over assumption, patience over premature conclusion, we honor his memory. Every time we feel wonder at the cosmos, while maintaining the discipline to understand it accurately, we embody his philosophy. The cosmos is all that is, or ever was, or ever will be. Within that cosmos, on one small world, a species arose capable of understanding its place in the vastness. Carl Sagan taught us how to exercise that capability responsibly. As 3i Atlas races onward to destinations unknown, we remain here on our pale blue dot, looking outward, learning, wondering, always seeking cosmic truth through the lens of science and reason that Sagan so brilliantly exemplified. Keep looking up. Keep asking questions. Keep demanding evidence. Keep feeling wonder. This is how we honor Sagan's legacy. This is how we continue the search for cosmic truth.